Yeah, I would characterize this talk as rather presenting an idea for a new kind of research design, which I find interesting and maybe holding some promise. And I'm very thankful for the opportunity to present it here right in this audience to get feedback from you, what you think about the potentials and problems maybe of this approach. So to give you an overview of what I'm going to talk about, for me, the starting point for this is the observation in the literature and also in our, some of our own studies that the within-person relations of variables can differ across people and can also differ from between-person correlations, leading to the question whether this might indicate individual differences in the strength of causal relations between these variables. And if one would be able to show such individual differences in causal effects, that could build a basis for individualized interventions. And trying to get at this, I'm proposing a kind of research design that combines the kind of research designs that Pratibha has been talking about this morning with between-person encouragement designs that have been used to some extent in the literature, and combine those into a within-person encouragement design. And I also spent some thought on how to analyze data from such a possible design, and there I'm proposing to use a combination of multi-level models and instrumental variable estimation, which I'm going to explain to you at least briefly in this talk. So for the conceptual starting point, this is an example of real data from the FLUX study last just mentioned, where we had 110 elementary school children doing working memory tasks for up to a month with several occasions per day. And what you see here is the average performance and the average task-related joy in doing those tasks. And you see there's a positive correlation between these two average measures. Now the question is, what does this correlation tell us about how these two variables are related within children over time? And actually it doesn't necessarily tell us anything, as you can see by just looking at, for example, these two children, which are very similar in their average levels of performance and motivation. But for this one child, you see that across occasions you have a pretty strong correlation of the two variables, and for this child you have zero correlation, which is because for this child up here, there is no systematic relation of the fluctuations in cognition and in enjoyment, while for this child on days when the joy of doing the task is low, typically also the performance breaks down. Now if one thinks about interventions, for example, about trying to improve performance by making the task more joyful, that might work for this child down here, but most likely will not work for this child up here. Now, observing such couplings is just a necessary precondition for a causal relation. That's what we're finally interested in. And it's not a sufficient condition. To really get at a causal relation of the two variables, we need experimental manipulation, maybe of the kind, or using the kind of research design that we've been hearing about this morning, like single case studies with ABA or ABAB designs. So I don't have to talk much about that anymore. Just want to mention that in these designs, what's typically compared are longer phases of baseline and treatment that is applied. What I'm thinking about are kinds of treatments that can also be looked at a shorter timescale level, thinking about what we just heard about different timescale levels. So about treatments that have relatively immediate but short-lived effects, maybe on a day-to-day level. And what also fits here is I wanted to mention that in this literature there have also been calls for more use of randomization in such single case designs. So maybe also going to shorter treatment phases which are not applied in a fixed sequence, but in change between treatment and control conditions with a random sequence. Yeah, the kind of treatment behaviors that I'm thinking about you can find nice examples for in a paper that I wanted to mention here. In the case you don't know that, it's a very nice long series of studies that a person called Seth Roberts has done on himself over years. So he tried to improve his sleep, mood, health, and weight by trying out all kinds of obvious and not so obvious, partly seemingly crazy things, like manipulating his sleep behavior, but also manipulating his television viewing behavior, manipulating the stuff he was eating and drinking, and so forth. And by using such within-person experimental manipulations, finding out about he functions and using that to generate hypotheses about how general interventions could look like. And that's exactly the kinds of treatments with relatively immediate and short-lived effects that I'm thinking about in the kind of studies and research design that I want to propose. Now the problem with this is that this person, Seth Roberts, he could do strict manipulation of these behaviors because he was doing the studies on himself. Now, if we do such experimental manipulation, or we want to do such experimental manipulations in real life with other people, then strict manipulation will often be impossible due to practical reasons. There might be things that people have to do that just keep them from showing a certain behavior in daily life. There could also be ethical constraints, like it's unethical to strictly keep people from showing a behavior that's beneficial for them or that they think is beneficial for them. So strict manipulation might not be possible, and that's why I think one possible solution to try out could be to not randomly manipulate the behavior itself, but to randomly manipulate encouragements to show a certain kind of behavior. And that is something that has been used also in educational research in between-person study designs. And here I use encouragement as an umbrella term for all kinds of things that could be done, like giving out vouchers, certain kinds of incentives, provide information, do advertisements, and so forth. So for example, in studies that wanted to look at the effect of going to a private school, their experimental manipulation was not possible, but it was possible to give out vouchers that provided financial support to a random subset of families, and then use that as an experimental aspect of the design. Or for example, for investigating the effects of watching Sesame Street, parents, a random subset of parents in a sample were provided with advertisements that explained how helpful watching Sesame Street can be for children. So the general idea is to randomize people in these classic designs into different conditions, either getting an encouragement or not, and then hoping that those who get the encouragement take the treatment and those who don't take the treatment, knowing that there will always be people who don't do what they're supposed to do, so you have those crossovers. And my idea is to use exactly the same logic, but now encourage people on a random subset of times that they could show a certain behavior, and make use then of this at least partly manipulated variance in treatment behavior. So to exemplify how I think such a study could look like is you first define an outcome and how this should be operationalized, so and measured in people's real life. So for example, experience sampling of self-reported mood. And then you choose a certain treatment behavior that you're interested in and where you think it could have a causal effect on this outcome variable, and think about how this can be operationalized in real life, and define a population of situations in which this behavior could be shown. So for example, going for a run in the morning measured with actigraphy recordings, if you're interested in the effect of physical activity on mood. Then you recruit participants who are interested in finding out whether such an intervention helps them improve their mood, and negotiate with them individual treatment regimes. So find out on what and which situations they might be able to show the behavior, and agree with them on what percentage of such situations they are willing to try to show the behavior. Then you implement the intervention, that is, use, for example, smartphones to provide encouragements to go running on a random 50% or so of mornings. And then, if you have enough data, I'll talk about that in a minute, estimate the treatment effect using instrumental variable estimation. So to illustrate how such a study could look like, and the results of such a study could look like for an individual person, is this here. So here, this would be the schedule that this participant has agreed upon to go for a run on a subset of Mondays to Thursdays, maybe with one exception here. This Wednesday, this person knows won't be able to go for a run, but this is the population of situations to start with. And then we as researchers provide encouragements on a random subset of these situations and observe that the behavior is shown adhering to some degree to these encouragements, but not perfectly. And also measuring the outcome on all of these occasions. And now we end up with outcome measures in situations where the treatment should have been shown and was shown, or the treatment shouldn't have been shown and wasn't shown. So that's what we want to see as many as possible of. But we also have situations where the reverse occurs. So now at an individual level, what we could do with this data is either compare treatment situations with control situations, either for the complete set of observations or only for those where the person behaved as the encouragements told him or her to. If one does that, one would face the potential problem of confounding effects, because the person might have selected to show the behavior in situations where he was feeling better anyways, or so, for example. So here, if one doesn't have a perfect adherence to the encouragement, one could have biased effects. One could also do an intent to treat analysis. So just compare the encouraged situations with the non-encouraged ones. That would tell us about the effect of the encouragement, but not about the treatment itself, but might also be interesting. So I think having such data for one individual could allow all kinds of more descriptive analysis, and maybe there could even be ideas to do some statistics also on the individual level. But I was thinking even one step further, and that is that if one would collect this kind of data for more than one person, but for a whole sample of participants, and for longer periods of time maybe than the one shown here, one might acquire large enough numbers of observations to think about this instrumental variable estimation method, which is typically a large sample technique that's used in quasi-experimental situations where one has a treatment and an outcome which correlate with each other, but where it's not clear whether there are confounding factors that also may partly explain this effect. And there, one then often tries to find a so-called instrumental variable, which is related to the treatment and the outcome, but where one can argue, based on theoretical grounds, that it's related to the outcome only because it's causally influencing the treatment and not for any other reasons or mechanisms. And if one can defend this assumption, this can be used in two-stage regression analysis to only take out the so-called exogenous part of variation in the treatment caused by the instrumental variable, and allow for causal inference of the effect of the treatment on the outcome. Not able to go in more detail here, but I can show you how this works in a path model. There one has the instrument, in our case that would be the encouragement, which influences or should influence the treatment behavior, and where the question is how much, how strongly this is related to the outcome variable. So you have these two causal paths that you assume, and you allow for a correlation of the residual terms of these two variables, which accounts for confounding factors that also make these two variables related. If the assumptions of this model are met, it allows us to get an unbiased estimate of the causal effect of treatment on the outcome variable. The assumptions are, first, you need as strong as possible instrument, so that there needs to be an effect of the encouragement on the treatment in our case, and the stronger that is, the better the method will work. And you have to assume or argue convincingly that there cannot be other direct effects, otherwise mediated effects of the encouragement on the outcome. That's something you have to think hard about and make sure that this is unlikely. But if these assumptions are met, you can estimate causal effects, and that's why I think this might be particularly interesting, is if you have this data in a multi-level context from several people, you can also look at individual differences in all kinds of parameters. And those are shown here. Those could be individual differences in the intercept of the outcome. So these are individual differences in baseline level of the outcome, irrespective of whether treatment behavior is shown or not. You can have individual differences in the baseline level of treatment behavior, irrespective of whether encouragements are given or not. And you can have individual differences in the strength of the relation of an encouragement and the treatment behavior. And you can have individual differences, those probably are most of the times the most interesting ones, individual differences in the strength of the relation of the treatment to the outcome. So these would be the individual causal effects. And all these individual differences you can model as random effects and look at the correlations among them, how these different aspects are related to each other, and also how they are related to other variables of interest. So by what personality variables, for example, these might be predicted. I started with so far only a small series of simulations to evaluate how well such an approach works, under which conditions, and here I so far varied the strength of the instrument, so how strong the adherence to the encouragements is with different levels, and also varied the strength of the true treatment effect, and looked at either 50 or 100 occasions, and a sample of either 50 or 100 participants, and did that with 1,000 replications per cell, and found what I think so far are relatively promising effects, that in cases where the effect of the encouragement on treatment is not very weak, you can, if either the treatment effect is of medium size or the treatment effect is even weak, but the encouragement effect is not too weak, or best possible case is if both are not too weak, you can get decent power to detect these effects with relatively large numbers of total numbers of observations. I mean, if you have 100 subjects, 100 occasions, you have 10,000 observations to work with. But I think it looks promising, especially acknowledging that this might be a relatively conservative naming for the different conditions, because what I call medium here means, if you translate it back to percentages, that people show the required behavior on 55% of the time. So if one manages to get them to show it on 60, 70, 80% of the time, these pictures should even look better. But there's definitely more work to be done, and there's problems to be discussed. I mean, if the instruments is weak, if people do not adhere to encouragements, that will not work very well. One has to carefully think about different ways that encouragements might influence the behavior. So for example, if somebody gets an encouragement to go for a run in the morning and this person cannot go running, but just because of the encouragement decides to do something else that's good for him or her, that might be the kind of effect you don't want to have here. And so here you have to think theoretically about such potential other mediators and maybe measure them and control for them, or do sensitivity analysis to find out how strong these different effects would have to be to reduce your effect of interest substantially. Then, I mean, we heard about that this morning. Autocorrelation is an issue for statistics here, and in the simulations that I did, autocorrelation is not taken into account. It's not possible in a straightforward way with M+. That's what I used here, but I think one could also set up these models in a similar way as mediation models have been set up in classic multi-level contexts to maybe also account for autocorrelation to some degree. And there could be all kinds of sequential dependencies in the data, in the sense that, for example, it might make a difference if you go for a run the third time in a row. If you go 5 times running in a row, that might have a negative effect. While only go 3 times, it might still be beneficial and things like that. There, I think, it also requires theoretical thinking and maybe also exploration of data. And if one has ideas about such sequential effects, one can try to control for them in the design, in the sequencing of the encouragements that one is using. And something that I only started to do is to include individual differences here, so the random effects that I was talking about, and found that if one wants to have up to 4 correlated random effects, these models really become demanding and take time. And so there really more simulation work will be necessary. And before summing up, I just wanted to mention a little bit the kind of work that we are doing in Frankfurt in the IDEA Center, where we had this Flux project with the main goal of assessing cognitive performance fluctuations in the school context, which I did together with my postdoc Judith Dirk and 3 doctoral students, Tanja Köhn, Jan Kühnhausen, and Anja Leonhardt, because this is work which I would like to build upon and maybe also using these ideas I just presented. And with this one study where we had these 110 elementary school children doing working memory performance assessments on smartphones and also affect ratings and measurements of potential antecedents of cognitive performance and effective well-being, up to 4 times a day in and out of the school context for a month. We, in a recently published series of papers, found several things that I think are also might be promising regarding these ideas. So, for example, we found systematic fluctuations on a day-to-day level in working memory performance for these children. We also found systematic fluctuations of different affect dimensions. And now taking just one variable that one might want to think about trying to getting to some degree under experimental control, we found that sleep variables were coupled with working memory performance with reliable random effects, so individual differences. It was not, for different children, had different strength of the relation of sleep quality and cognitive performance, and the same for affect dimensions. There also we found couplings of these variables, but individual differences in the strength of these couplings. And so the kind of study that I'm currently working on getting funding for would be one where one has a baseline phase in which one finds that for different children, different variables might be predictors of, for example, working memory performance, and then use this information to add an intervention phase where one, using such encouragements, encourages behaviors that look like could be causally effective for individual children. So this first child would get encouragements to go to bed early, for example, and this other child would get encouragements to play ball games during school breaks or something. So trying to get at this individualized intervention ideas that if one finds that there actually are these causal effects on an individual level, could help the long-term goal of longer-term behavioral change and outcome improvement. So to sum up, I think this kind of design might be helpful to investigate relatively immediate and short-lived causal effects that might underlie the observed within-person couplings that we see in our studies, and taking those into the wild, so into ecologically valid contexts, thereby broadening the applicability of single-case experimental designs. And it also would be, I think, perfectly suited to this movement that we were just talking about, this self-enhancement, self-quantification, to allow people to do self-experimentation with what helps them to feel better, to perform better, and whatever in their everyday lives. That's it. Thank you very much.